Hey everybody, this is Tech Teach again, and we're in our final lesson on gears. And yesterday's lessons, we were looking at the gear ratios, and we were using all the formulas that are up here. We use the gear ratio, um, which is the mechanical advantage of two gears or three or four gears put together. When you put more than two gears together, it's called a gear train. When you put two gears together, they rotate in opposite directions. We said if you put a third gear in the middle gear becomes the idler gear, and the purpose of the third gear is to make the gear train the first and last gears rotate in the same direction. So now we're just going to take a quick review of the things that we learned yesterday and then move on into sprockets and pulleys to finish up the assignment. The first thing is a gear ratio. If you want to know what the gear ratio of something is, then you need to look at the clues that the gears give you. Clues could be the number of teeth in a gear. So I'm looking up here at the two gears here, and the small red one has 6 teeth, and the large blue one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, has 12. So 6 to 12. So, what's our gear ratio going to be? You can count the number of teeth, and you put the number of teeth in the out gear and divide it by the number of teeth in the in gear, 12 over 6. 12 divided by 6 is 2. So 2 will go over here. Another clue that you can get is the diameter, the size of the gears. So if you have a 2-to-1 gear ratio, that the size of this gear is going to be exactly half of the size of that gear. So the math works out real easy in this case. It doesn't always work out that way, but if you have a 4-inch gear here, you'll have a 2-inch gear there with a 2-to-1 gear ratio. And then the next one's a weird one. It's like the speed of, or the RPMs, revolutions per minute, or rotations per minute. And so in this case, our big gear rotates 40 times in a minute, and our smaller gear, whoop, that must be wrong. This is omega n. So our in gear is going to be our smaller gear here. And it revolves at 40 revolutions per minute, and it's going to go on top. And then the bigger gear is going to be slower because it has more teeth to have to go through per revolution. So it's only going to turn 20 revolutions per minute. So 40 divided by 20 is your formula for speed, revolutions per minute. And then the last one is the torque. If you know one of the two torques, then you can calculate the other torques. So we had 40 revolutions per minute here, and we had 20 revolutions per minute there. So you could use formulas to calculate how much torque is applied. If you know one of these, if you knew this was 40, then you could also know that that would be 80 because it would be 2-to-1. So we said that these are all interchangeable, and you can set them up so that you can multiply them against each other. If you say GR equals N out over N in, then you're cross multiplying these to calculate. But you can say GR over 1 equals D out over DN, or it equals W out over WN over W out. And you could also switch it up and say D out over DN equals WN over W out, so on. So they're all interchangeable. So we know the answer to this particular slide here is 2 over 1. So in the next lesson, you're going to learn about combination gears, where you have two gears that are being spun by the same shaft. And there's a little trick to calculating the gear ratios and things, but you'll still use the same formulas. You'll also, in pulleys, you'll have the same formulas, and in gears and sprockets, like on a bike chain and that kind of stuff, you still have the same formulas that you're using. The benefit of a gear and sprocket is that you don't have any slippage, but on a pulley system, sometimes the pulley will slip and squeal. I think we've all heard the fan belt of a car squealing, that kind of stuff. So good luck with this stuff, and move on to the next lesson, and I'll see you in a minute.